Okay, so we have this nice problem involving two cash flows, and there seems to be some confusion about what's going on in the exponents of the growth factor. In particular, there's an issue of why is it raised to the 2 times 20 as opposed to 2 times 5. So we're going to go through this problem. So Winston deposits $10 into a fund today, aka time zero, and $20 15 years later, which we're going to call time 15. Interest is credited at a nominal discount rate D, which is unknown, compounded quarterly for the first 10 years, and a nominal interest rate of 6% compounded semi-annually thereafter. The accumulated balance in the fund at the end of 30 years is $100. Find D. Okay, so this will end up being basically an equation matched at time 30. So we know at the end we have $100, so we're going to make that the right-hand side of the equation. The left-hand side of the equation will be taking our two cash flows, $10 and $20, and basically putting them together with their growth factors. Okay, so let's start with the first one. So the first one, what's going on? From time 0 to time 10, we're working with this discount rate. And from time 10 to time 30, we're working with this nominal interest rate. Okay, so what is the total value at time 30? Well, we take the 10 initial, multiplied by the growth factor for the first 10 years. Well, it's a discount rate compounded quarterly. So it's going to be 1 minus d over 4 raised to the power of 4 times 10 with a negative sign in front of the exponent. The negative sign in front of the exponent is to ensure that the discount rate, which normally takes money in the future and calculates the present value, what we're doing now is we're doing the opposite. We're taking money presently and we're seeing what's the value at time 10. So that's why there's a negative sign to ensure that this discount is a true growth factor. Okay. Then once we get to time 10, we have to go until time 30. So this is a total of 20 years where we're using this nominal interest rate compounded semi-annually. So that's where we get this next growth factor in red, which is 1 plus 0.06 divided by 2 for semi-annually. Well, if it's 2 times per year, and it's a total of 20 years between 10 and 30. So there we go. Now the question is, why was it 2 to the 20, 2 times 20, and not 2 times 5? My guess is the student is confused because at time 10 is when the rate of interest changes from a discount rate to a nominal interest rate, and time 15 is when we get this $20 cash flow. So my guess is they got this 5 going from 10 to 15, but it's not 10 to 15. It's 10 to 30. So that's why it's 2 times 20. Okay. If we go to the blue, next cash flow, well, the cash flow occurs at time 15 and it compounds for 15 years. It's nothing to do with this discount rate. We apply the nominal interest rate, and this is a standard formula, and you get 20 times 1 plus 0.06 divided by 2 raised to the power of 2 times 15 for 15 years. Okay, from here, we've done all the hard part, and we just solve an algebra problem at time 30. So equating cash flows, it's straightforward. The number in blue is easy to simplify on a calculator to 48.55. The number in red, most of it you can figure out on a calculator. The only part you have to remain unknown is this 1 minus d over 4 term. But the point is you end up getting 32.62, 1 minus d over 4 to the negative 40 plus 48.55 equals 100. So now simple algebra, subtract 48.55 from both sides, divide by 32.62 from both sides. You end up being able to isolate 1 minus d over 4 to the negative 40 equals 1.577. So you take both sides here, raised to the negative 1 over 40th power will kill this exponent. And you get 1 minus d over 4 equals 0.9887. And from here, it's straightforward to solve for d. D ends up being 0.0453, or in other words, 4.53%. So I hope this helps answer the question.